All right, so this is section 11.5 again, or for the first time. I think this will end up being the first video. And we're looking at qualitative and or categorical data and quantitative data and trying to tell the difference between them. So qualitative or categorical data, as you can see, consists of labels or non-numeric entries that can be separated into different categories. So when you're using qualitative data, there's a lot of operations that don't make sense, like adding something to the data set, as we saw in section 11.1, or finding the mean. Oftentimes finding the median doesn't make sense. So there's a lot less you can do with qualitative data than you can, or categorical data, than you can with quantitative data. And quantitative data just consists of regular numbers, counts, measurements, that sort of thing. So things like temperature, height, weight, those are all quantitative data. But if you think about other things like color or what are some other examples? Color, political party affiliation, stuff like that. Those are just categories that you can put things into. This isn't totally exactly the same thing, but qualitative data is more like something that's discrete data points, and quantitative data is more of a continuous data point. But let's look at some examples of checking some whether or not some data is qualitative or quantitative. So the first one is the prices of used cars at the dealership. This is a great example of quantitative data. Pretty much anything that involves money is going to end up being quantitative data, because the prices of used cars at the dealership, if you think about it, the dealer could choose basically any price for their cars. And it makes sense that you would look at an average of the price of the cars at the dealership. And each individual price doesn't really make sense as being just a discrete category. Now, the jersey numbers on a basketball team, this is an interesting example because you might be tempted to just say quantitative data is numbers, qualitative data is not numbers. But this one, jersey numbers on a basketball team, is actually qualitative or categorical data. And the reason for that is you need to think about whether or not it makes sense to find a mean of the jersey numbers on a basketball team. And you're going to think about this and you're probably going to say, well, no, of course not. It doesn't make sense to actually calculate a mean number of it, because the numbers themselves, the jersey numbers, don't actually mean anything. They're just essentially arbitrary numbers that are put on a jersey. So that one would definitely be qualitative data or categorical data, despite the fact that it seems like it's numeric. The jersey numbers are in effect just labels. Now, the length of songs played at a concert would be quantitative data. Time is another thing that's very commonly considered to be quantitative data, because it makes sense to think about, well, what's the average song of a band that you might like, or an artist you might like? It makes sense to think of the average of that or the median number of that, because it's a continuous measurement. While usually songs aren't exceptionally long or exceptionally short, you can still think about you can still imagine, and there's still a meaningful distinction between, a song like In-A-Gadda-Da-Vida that's 17 minutes long and September 63 or whatever that song is, that's like 2 or 3 minutes long. There's still a meaningful difference, and talking about the differences and the averages and stuff like that actually makes sense. Now, the last one, zodiac signs of students in your class, should be quite obvious. That's categorical or qualitative data. It obviously has no numeric association at all, and it's just, can you put students into discrete categories of zodiac signs? So that one's pretty straightforward. And if we check our various solutions here, prices are numerical entries. There's quantitative. Jersey numbers are numeric, but they are labels. Like I said, song lengths are numeric measurements, and zodiac signs are obviously non-numeric entries. So a couple more examples. We have telephone numbers in a directory, length of videos on a website, ages of patients at a hospital, and types of flowers at a florist. So beginning with the last one, types of flowers at a florist, I think that is pretty obvious. That one is just qualitative. Flowers obviously are not numeric in any respect at all. Now, if we're counting the number of each type of flowers, that would be another thing. But since it's just the types of flowers, we can just say, all right, well, there are lilies and there are pansies and marigolds. It's just flowers. Now, By contrast, length of videos on a website, that one is extraordinarily similar to length of songs played at a concert. They are numeric measurements, so the data is going to be quantitative. The age of patients at a hospital is the same thing. Age is another numeric measurement, so it makes sense to think of that as being quantitative data as well. And finally, telephone numbers in a directory. This is another interesting one because the telephone numbers in a directory are numeric, they're numbers, but it doesn't really make sense to take an average of those numbers. Because if you think about the telephone numbers in a directory, it's like if you found the average of them, what would that actually tell you? It wouldn't tell you anything. So even though telephone numbers are numbers, they're qualitative data because it doesn't make sense to do any of those operations on telephone numbers because they're not really connected in any meaningful way, in contrast to ages of patients and the length of videos on websites.